Dorky Dara again!
The first step of a related rates problem is to draw a picture. We are trying to calculate how fast Emily was sliding when her head was 4 feet from the ground. So, here's Emily's head. Here is the wall that she's standing on. Here's Emily's body. Emily, according to my calculations, is approximately 5 feet tall, and this is going to be 4 feet. So, here we have this line, which would be the ground. Luckily, I was there when Emily went down, so I know that Emily's feet were sliding out at a rate of 2 feet per minute. Step 2 is to determine what we are looking for. I would like to know how fast is Emily sliding when her head is 4 feet from the ground. In this case scenario, we are looking for dy dt. We know that y equals 4 feet because y is when Emily is 4 feet from the ground. We also know that z equals 5 feet because Emily is 5 feet tall. The last thing we know is that dx dt equals 2 feet per minute. In other words, just 2. Now it's time to establish a relationship between the variables. In this case scenario, since we have a triangle, it's going to be z squared equals x squared plus y squared. Step 5 is to take the derivative of our relation function. So we are going to have 2z equals 2x plus 2y. You'll notice that me, silly dorky Dara, forgot nearly the most important part of the problem. We forgot dz times dz dt equals 2x times dx dt plus 2y times dy dt. Before we substitute the variables, we should simplify our equation. We do not know x yet, so we have x and we'll keep the variable there, and dx dt is 2 feet per minute, plus y, which is 4 feet, times dy dt, which is what we're looking for. To solve for x, we need to use the Pythagorean theorem. So we're going to have z squared, which is 5 squared, equal x squared plus 4 squared, which is y. So now we're going to solve for x. We know that 25 equals x squared plus 16. Then we can subtract 16 from both sides, so we have 9 equals x squared. Therefore, x equals plus or minus the square root of 9. Now x equals plus or minus 3. We are going to use positive 3 because you can't have a negative length. Now we will solve this equation with all of our variables plugged in. So this is going to be 0 equals 6 plus 4 dy dt. We can now subtract 6 from both sides. So we have negative 6 equals 4 dy dt. Now we can divide by 4 so that we have dy dt. So now the answer to dy dt is negative 3 halves. We know that dy dt cannot be negative because speed is always positive. So we have discovered that Emily's head is traveling down the wall at a rate of 3 halves feet per second when her head is 4 feet from the wall.